지난 1월 7일 라스베가스에서 CES2025가 4일간 열렸는데요. 그 중에서 엔비디아의 발표가 화제를 일으켰습니다. 작년 발표에서는 GPU 자체에만 국한되는 면이 있었는데요. 이번에는 훨씬 더 넓은 범위의 상품으로 충격을 더했습니다. 이 발표는 1시간 반 분량이지만 이번 영상에서 약 20분간의 필수 내용으로 축약해봤습니다. 그럼 시작합니다.
Welcome to CES! Here it is, our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 4,000 TOPS, 4 petaflops of AI. 3 times higher than the last generation Ada. This is RTX 4090. I know many of you have one. Well, now with the Blackwell family, RTX 5070, 4090 performance at 549. And here's the whole family, starting from 5070 all the way up to 5090. 5090, twice the performance of a 4090. Of course, we're producing at very large scale availability starting January. Well, it is incredible, but we managed to put these gigantic GPUs into a laptop. This is a 5070 laptop. This 5070 laptop has a 4090 performance. Can you imagine? You get this incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Well, you can't do that without artificial intelligence. So we ray trace only the pixels we need, and we generate, using artificial intelligence, all of the other pixels we have. As a result, the amount of energy efficiency is just off the charts. The future of computer graphics is neural rendering, the fusion of artificial intelligence and computer graphics. We used, of course, programmable shading and ray traced acceleration to produce incredibly beautiful pixels. But then we have artificial intelligence be conditioned, be controlled by that pixel to generate a whole bunch of other pixels. It has been trained on a supercomputer back in NVIDIA, and so the neural network that's running on the GPU can infer and predict the pixels we did not render, generating 3 additional frames for every frame that we calculate. So we need to create the world model, as opposed to GPT, which is a language model. And this world model has to understand physical dynamics, things like gravity and friction and inertia. It has to understand geometric and spatial relationships. It has to understand cause and effect. And so all of these types of intuitive understanding that we know, most models today have a very hard time with. We need a world foundation model. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it. The next frontier of AI is physical AI. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos. Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI. NVIDIA Cosmos, world foundation model, focuses on physical dynamic things. It's really about teaching the AI to understand the physical world. Today we're announcing that Cosmos is open licensed. It's open available on GitHub. And so the combination of the two gives you a physically simulated multiverse generator. And we have a growing number of ecosystem partners connecting to Omniverse. And the reason for that is very clear. Everybody wants to digitalize the future of industries. There's so much waste, so much opportunity for automation in that $50 trillion of the world's GDP. The next example, autonomous vehicles. The AV revolution has arrived. After so many years with Waymo's success and Tesla's success, it is very, very clear autonomous vehicles has finally arrived. Each car company might work with us in a different way. Waymo and Tesla, of course, in their data center. BYD, Mercedes, because a fleet of cars coming with NVIDIA starting this year, going to production. And I'm super, super pleased to announce that today, Toyota and NVIDIA are going to partner together to create their next generation AVs. 100 million cars built each year, a billion vehicles on the road all over the world, 1 trillion miles that are driven around the world each year. That's all going to be either highly autonomous or fully autonomous coming up. And so this is going to be a very large industry. I predict that this will likely be the first multi-trillion-dollar robotics industry. In just a few of these cars that are starting to ramp into the world, our business is already $4 billion, and this year, probably on a run rate of about $5 billion. So really significant business already. This is going to be very large. Well, today we're announcing that our next generation processor for the car, our next generation computer for the car is called Thor. Okay, this is Thor. This is a robotics computer, takes sensors, madness amount of sensor information. And this chip has to process all that sensor and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard of autonomous vehicles today. The second part of our drive system that I'm incredibly proud of is the dedication to safety. Drive OS, I'm pleased to announce, is now the first programmable AI computer that has been certified up to ASIL D, which is the highest standard of functional safety for automobiles. The only and the highest. And so I'm really, really proud of this. But I want to show you how we use the car to reconstruct digital twins automatically using AI and use that capability to train future AI models. Okay, let's play it.
The autonomous vehicle revolution is here. Building autonomous vehicles, like all robots, requires 3 computers. NVIDIA DGX to train AI models, Omniverse to test drive and generate synthetic data, and Drive AGX, a supercomputer in the car. Building safe autonomous vehicles means addressing edge scenarios, but real-world data is limited, so synthetic data is essential for training. The Autonomous Vehicle Data Factory, powered by NVIDIA Omniverse, AI models, and Cosmos, generates synthetic driving scenarios that enhance training data by orders of magnitude. First, OmniMap fuses map and geospatial data to construct drivable 3D environments. Driving scenario variations can be generated from replayed drive logs or AI traffic generators. Next, a neural reconstruction engine uses autonomous vehicle sensor logs to create high-fidelity 4D simulation environments. It replays previous drives in 3D and generates scenario variations to amplify training data. With Cosmos Nemotron Video Search, the massively scaled synthetic dataset, combined with recorded drives, can be curated to train models. NVIDIA's AI Data Factory scales hundreds of drives into billions of effective miles, setting the standard for safe and advanced autonomous driving.
The AV industry is here. This is an incredibly exciting time. Super excited about the next several years. I think you're going to see, just as computer graphics was revolutionized such incredible pace, you're going to see the pace of AV development increasing tremendously over the next several years. And now, agentic AI. AIs that can perceive, reason, plan, and act. And then the next phase, some of which we'll talk about tonight, physical AI. The ChatGPT moment for general robotics is just around the corner. If we could possibly build these amazing robots, we could deploy them in exactly the world that we've built for ourselves. These 3 robots are, 1, agentic robots, agentic AI. You know, they're information workers. So long as they could accommodate the computers that we have in our offices, it's going to be great. Number two, self-driving cars. And the reason for that is we spent 100 plus years building roads and cities. And then number three, human or robots. If we have the technology to solve these three, this will be the largest technology industry the world's ever seen. We think that the robotics era is just around the corner. The critical capability is how to train these robots. In the case of human or robots, imitation information is rather hard to collect. The reason for that is in the case of car, you just drive it. We're driving cars all the time. In the case of these human or robots, the imitation information, human demonstration is rather laborious to do. And so we need to come up with a clever way to take thousands of human demonstrations, use artificial intelligence and omniverse, millions of synthetically generated motions. And from those motions, the AI can learn how to perform a task. Let me show you how that's done.
Developers around the world are building the next wave of physical, AI-embodied robots, humanoids. Developing general-purpose robot models requires massive amounts of real-world data. NVIDIA Isaac GR00T helps tackle these challenges, providing humanoid robot developers with four things: robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The NVIDIA Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large data sets from a small number of human demonstrations. Operators can capture data even without a physical robot, and they can operate the robot in a risk-free environment, eliminating the chance of physical damage or wear and tear. To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations. Then use GR00T Mimic to multiply these trajectories into a much larger dataset. Next, they use GR00T Gen, built on Omniverse and Cosmos, generating an exponentially larger dataset. The Omniverse and Cosmos Multiverse Simulation Engine provides a massively scaled dataset to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Sim before deploying to the real robot. The age of general robotics is arriving, powered by NVIDIA Isaac GR00T.
NVIDIA Isaac GR00T. This is our platform to provide technology elements to the robotics industry to accelerate the development of general robotics. Wait for it. All right. So this NVLink system, this right here, GB200 NVLink 72. It is 1.5 tons, 600,000 parts, approximately equal to 20 cars, 120 kilowatts. It has a spine behind it that connects all of these GPU together, 2 miles of copper cable, 5,000 cables. This is being manufactured in 45 factories around the world. We build them, we liquid cool them, we test them, we disassemble them, ship them in parts to the data centers because it's 1.5 tons. Blackwell, over our last generation, improves the performance per watt by a factor of 4. Performance per watt by a factor of 4, performance per dollar by a factor of 3. That basically says that in one generation, we reduce the cost of training these models by a factor of 3. Or if you want to increase the size of your model by a factor of 3, it's about the same cost. And every single data center is limited by power. And so if the perf per watt of Blackwell is 4 times our last generation, the revenue that could be generated in the data center is increased by a factor of 4. One chip here is 1.4 exaflops. The world's largest supercomputer, fastest supercomputer, only recently, this entire room's supercomputer only recently achieved an exaflop plus. But here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips. And right now with GPT-01, Gemini Pro, and the new the 01, 03 models, they're talking to themselves, reflecting, they're thinking. And so, as you can imagine, the rate at which the tokens could be ingested is incredibly high. And so we need the token rates, the token generation rates, to go way up. And we also have to drive the costs way down simultaneously so that the quality of service can be extraordinary, the cost to customers can continue to be low, and AI will continue to scale. And so that's the fundamental purpose, the reason why we created NVLink. This incredible project that we started about a decade ago. Inside the company was called Project Digits, Deep Learning GPU Intelligence Training System. Digits. The reason why we built it was because we wanted to make it possible for researchers and startups to have an out-of-the-box AI supercomputer. Imagine the way supercomputers were built in the past. You really have to build your own facility, and you have to go build your own infrastructure, really engineer it into existence. And so we created a supercomputer for AI development for researchers and startups that comes literally one out of the box. I delivered the first one to a startup company in 2016 called OpenAI, and Elon was there, and Ilya Sutskever was there, and we celebrated the arrival of DGX-1. It revolutionized artificial intelligence and computing. Every software engineer, every creative artist, everybody who uses computers today as a tool will need an AI supercomputer. And so I just wish that DGX-1 was smaller. This is NVIDIA's latest AI supercomputer. This sits, well, somewhere, and it's wireless or connected to your computer. It's even a workstation if you like it to be. And you could access it like a cloud supercomputer, and NVIDIA's AI works on it. It's based on a super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. This little thing here is in full production. We're expecting this computer to be available around May timeframe, and so it's coming at you. This is what it looks like. Who doesn't want one of those? And if you use PC, Mac, anything, because it's a cloud platform, it's a cloud computing platform that sits on your desk. You could also use it as a Linux workstation if you like. If you would like to have double digits, this is what it looks like. It's like a supercomputer. Our entire supercomputing stack is available. NVIDIA Project Digits. I told you that we are in production with 3 new Blackwells. Not only is the Grace Blackwell supercomputers, NVLink 72s, in production all over the world's first physical AI foundation model is open, available to activate the world's industries, and 3 robotics, agentic AI, humanoid robots, and self-driving cars. It's been an incredible year. I want to thank all of you for your partnership, thank all of you for coming, and look forward to the next year.
이상이 발표 핵심 내용이었는데요. 어떠셨나요? 사람의 노동이 생각보다 빠르게 대체될 것 같지 않나요? 이 영상을 토대로 2025년 잘 데뷔하셔서 지혜로운 한 해 보내시길 바랍니다.
Happy New Year! Thank you!